Welcome to another deep dive. Today we're heading to the Canadian Maritimes.
The Maritimes?
Yeah, Nova Scotia, New Brunswick, Prince Edward Island.
Ah, okay.
We're diving into the fascinating world of geology with Acadian geology.
Acadian geology sounds pretty comprehensive.
It is. It's got everything from maps and formations to fossil discoveries, even economic geology.
Mining and such.
Exactly. So our mission, should we choose to accept it, is to understand this region's geological timeline.
Sounds like a journey through time.
It is. Okay, so the book talks about Acadia, but I thought that wasn't always the name for these provinces.
You're right. It's kind of interesting how that came about.
Hmm.
Early French settlers, well, they heard the Micmac people using Acadie.
Like Shubenacadie.
Yeah, exactly. They used it for places with abundant resources, like Shubenacadie meant a place with lots of groundnuts.
Groundnuts.
Yeah, like peanuts. But anyway, the settlers thought Acadie was the name for the whole region.
Wow, a misunderstanding that ended up naming a region.
Exactly. Linguistic history is full of surprises.
Okay, well, names aside, what really gets me is the sheer range of geological periods represented in these provinces. The book mentions everything from the Silurian to the Triassic.
Don't forget the Carboniferous.
Oh, right, the Carboniferous, of course. But it's hard to picture these periods just stacked on top of each other.
You'd think it'd be like a layer cake, right?
Yeah, exactly.
But it's way more dynamic than that. The periods interact. Those old Silurian rocks, over 400 million years old, they influence the Carboniferous coal deposits.
Wait, really? So it's like geological dominoes.
Perfect analogy. Each period influencing the next.
So tell me more about the Carboniferous. I know it's famous for coal, especially in the Maritimes.
It is. Imagine vast, swampy forests millions of years ago, teeming with plant life. When these plants died, their remains piled up, getting buried under sediment.
And under all that pressure, it turned into coal.
Over millions of years, yes.
Yeah.
The pressure and heat transform this organic material into the coal we use today.
Okay, that makes sense, but I'm having trouble picturing it.
Well, luckily, we have some incredible fossilized forests in Nova Scotia. Places like the Joggins Cliffs.
Those cliffs are from the Carboniferous.
Absolutely. They're like vertical slices through time, revealing those swampy layers where the coal formed. You can walk through these fossilized forests.
Wow, that would be amazing to see.
It is. You see the layers of coal in the cliffs. It really helps you visualize the process.
So it's not just about digging up coal, it's about understanding the story behind it.
Precisely. Millions of years of Earth's history went into creating this resource. And the Carboniferous is just one chapter in the epic story of the Acadian provinces.
Oh, right, there are other periods too. The Devonian, wasn't that the Age of Fishes?
It was. And then there's the Silurian, a time of dramatic changes in sea level and continental collisions.
Whoa, hold on. I need a moment to process all these periods.
Take your time. It's a lot to take in.
Okay, let's go back to the Carboniferous for a minute. The book mentions different types of coal found in the Maritimes. Bituminous, anthracite. What's the difference?
Good question. The type of coal is directly related to the geological formation it comes from.
So different formations, different types of coal.
Think of it like this. The longer the coal is buried, the higher its rank.
Mhm.
Anthracite coal, that's the highest rank.
Because it's been under pressure for longer.
Exactly. It's been subjected to the most intense heat and pressure. So it's harder, contains more carbon.
So it's like coal gets refined over millions of years, depending on the geology.
Just precisely. And that affects its properties and uses.
This is already more interesting than I thought it would be. Okay, Carboniferous, Age of Fishes, colliding continents, what else?
Well, Acadian geology doesn't just focus on rocks. It dives into fossils, too.
Oh, fossils, like dinosaurs.
Well, not dinosaurs in this case. More like fossilized raindrops and ripple marks, ancient plants and reptiles.
Fossilized raindrops. That's incredible. It's like a window into a prehistoric rainstorm.
It really is. And that's just the beginning. The book also details the discovery of fossilized reptile footprints at Horton Bluff.
Reptile footprints. I'm picturing giant dinosaur tracks.
Not quite dinosaur-sized, much older. These are from the Carboniferous period.
Wow, so before the dinosaurs.
Way before. And it was a big deal because it was the first evidence of reptiles existing that far back.
So they challenged previous scientific understanding. That's huge.
It was. And the book goes on to describe these early amphibians and reptiles.
Like what? What kind of creatures?
Creatures like Dendropiton and Hylonomus, found in fossilized tree stumps.
Wow, inside fossilized tree stumps. That's crazy.
It is. It really brings those ancient ecosystems to life.
This is already so much more than I expected. I'm starting to see these ordinary landscapes in a whole new light.
That's the beauty of geology. It reveals the hidden stories beneath our feet, connecting us to a past that's almost unimaginable in its scale.
I'm hooked. Okay, so we've talked about the Carboniferous and its coal-forming swamps, the age of fishes colliding continents, and fossilized raindrops and reptiles. What other wonders await us in this geological journey through the Acadian provinces?
Well, we've been so focused on the Carboniferous, we haven't even talked about some other amazing periods, like the Triassic period, which is practically synonymous with red sandstone.
Red sandstone. But isn't that pretty common?
It is, but the Triassic sandstone in the Maritimes tells a specific story. It helps us understand the climate and environment of that time period.
So it's not just about the rock itself, it's about what it reveals about the past.
Precisely. And the story gets even more dramatic when we consider the volcanic activity that shaped the region.
Volcanoes in the Maritimes. Really?
Oh yeah. Acadian geology describes these intrusive granite formations, molten rock pushing up through existing layers.
So not necessarily explosive volcanoes.
More like slow, powerful intrusions transforming the landscape from within.
Wow, I never would have pictured that. And speaking of impact, we can't forget the economic side of things.
You're right. The book definitely talks about the economic implications of all this,
Wait,
especially for mining.
mining makes sense.
It describes iron, gold, and copper deposits, and how those resources have shaped the Maritimes.
Wow, it's fascinating to see how those ancient geological processes are still shaping our world today.
It's a reminder that Earth's history is not just a collection of facts, it's a story that's still unfolding.
I'm already looking forward to the next chapter.
Well, get ready, because we're diving even deeper into specific periods and discoveries in Part 2. Welcome back to our deep dive into Acadian geology. Ready for more?
Absolutely. I'm eager to see what other geological wonders we uncover today.
Well, we left off talking about all the different periods represented in the Maritimes.
Right, like the Carboniferous, Devonian, Silurian, even the Precambrian.
Exactly.
Yeah.
And Acadian geology doesn't just give us a broad overview, it dives into specific locations.
Oh, like what? What kind of places?
Well, for instance, there's the South Joggins region of Nova Scotia.
South Joggins.
Yeah, it has this amazing coastal section that's essentially a complete record of the entire Carboniferous period.
Wait, a complete record? That's incredible.
It is. The book emphasizes how important this section is for understanding the sequence of events that shaped the Maritimes during the Carboniferous.
Okay, so we're talking about a period when the land was underwater, and then periods where it was dry land, all reflected in the layers of rock.
You got it. Imagine walking along the coast, looking at those exposed layers in the cliffs. You might see a layer of limestone packed with marine fossils.
Like what kind of marine fossil?
Oh, things like brachiopods and corals, indicating that the area was submerged under a shallow sea.
Okay, so that layer is like a snapshot of an ancient ocean.
Exactly. Then the next layer might be sandstone, formed from sand deposited by rivers and streams.
So that means the sea had retreated.
Exactly. And you might find fossilized plants in that sandstone, maybe even footprints from those early reptiles.
Whoa, those footprints were preserved for millions of years.
It's amazing, right? Each layer is like a time capsule. And Acadian geology does a fantastic job of guiding us through these layers, explaining what they tell us about the environment.
So it's like a step-by-step guide to the Carboniferous.
Pretty much. For example, it focuses on one specific layer, Subdivision 7-7. It tells a fascinating story about an ancient forest.
Subdivision 7th, huh? Okay, I'm all ears. What's so special about this subdivision?
Well, it captures the moment when a massive sigillaria tree was buried upright.
A whole tree, just buried.
Yeah. Imagine this giant tree, trunk still standing, encased in sediment. The book suggests a massive flood was the culprit, bringing sand and driftwood.
Wow, so the tree got buried during a flood.
It seems that way. But what's even more interesting is that the tree didn't die immediately.
What? It survived being buried.
For a while, yeah. The sediment shows it kept growing, with its top poking above the sand.
That's incredible.
Isn't it? Talk about resilience. But eventually, more sediment piled up, and the whole tree was buried, preserved for millions of years.
It's mind-boggling to think about how much information we can get from a single fossilized tree.
It really is. It's a window into a long-lost world, a world of giant trees and dramatic events.
Speaking of dramatic events, you mentioned that South Joggins records the entire Carboniferous period.
Right.
Does that mean it also shows those coal deposits?
It does. The book describes how the South Joggins cliffs reveal layers upon layers of coal.
Interspersed with those other rock types we talked about?
Exactly. Each layer telling its own story.
It must be amazing to see those layers and know you're witnessing millions of years of history.
It is. And the book helps us interpret those layers to understand the formation of coal, the changes in climate, all of it.
So Acadian geology isn't just presenting information, it's guiding us through it.
You got it. It even gets into some debates among geologists, like the exact nature of coal formation.
Oh, I thought that was pretty straightforward. Plants dying, getting buried, turning into coal.
Well, it turns out it's a bit more complicated than that. There's debate about whether it was primarily a submerged or a subaerial process.
Submerged versus subaerial, huh? I'm not familiar with those terms.
Basically, did those plants accumulate underwater or on dry land?
Ah, okay, so which is it? I always pictured those vast, swampy environments.
Right, that's the traditional view, that coal formed underwater. But the book points out that if that were true, we'd expect to find marine fossils mixed in with the plant material.
That makes sense. If those plants were always submerged, there would be sea creatures living among them.
Exactly. But the fossil record shows that marine fossils in coal seams are actually pretty rare.
Really? So, does that mean coal formed on dry land?
The book suggests that coal formation happened in forested areas that were periodically flooded, but not permanently submerged.
Okay, so like a cycle. Trees growing, a flood buries the plant debris, then the cycle starts again.
Exactly. And over millions of years, these cycles created the thick coal seams we see today.
It's like a giant layer cake, each layer representing a different flood event.
I like that analogy. It really captures the dynamic nature of coal formation. It wasn't just one thing. It was an interplay of different environments over millions of years.
This is so much more complex than I ever imagined.
And that's just the Carboniferous. There's so much more to explore the Acadian provinces.
Can't wait. Where do we go from here? Back in time, maybe.
Excellent idea. Let's journey back to the Devonian period, a time known as the Age of Fishes.
The Age of Fishes sounds exciting.
It is. The Maritimes have some remarkable Devonian rocks that help us understand this pivotal period in Earth's history, a time when fish were diversifying and our distant amphibian ancestors were just starting to emerge from the water.
Okay, I'm ready to dive into the Devonian. What kind of evidence do we have from the Maritimes?
Well, Acadian geology focuses on two main areas for Devonian rocks, one in southern New Brunswick and another in northern Nova Scotia, each telling a different part of the story.
Two different perspectives on the Devonian world, huh? Let's start with the New Brunswick site. What makes that one special?
This site, known as the Fern Ledges, is famous for its exceptionally well-preserved plant fossils.
Plant fossils? Like what?
Delicate fern fronds, preserved in such detail you can see the individual veins. It's like stepping back in time to a Devonian forest.
Wow, I never would have pictured fern fossils. What can we learn from them? About the environment back then, maybe.
The book describes a diverse ecosystem of early land plants, ferns, lycopods, even some early seed plants, a time when plants were just starting to colonize the land.
So we're seeing the ancestors of our modern forests. That's amazing.
It is. And it's not just plants. The book mentions animal fossils at the Fern Ledges, too. Eurypterids, also known as sea scorpions.
Sea scorpions? Those sound terrifying. How big were they?
Some were over 6 feet long. Imagine encountering one of those in the Devonian seas.
Yikes. Okay, so ancient ferns, giant sea scorpions. What else did the Fern Ledges tell us?
Well, the book emphasizes how these fossils help us understand the ecological interactions of the Devonian. These plants and animals were part of a complex web of life, shaping those early environments.
So we're learning about predator-prey relationships, food webs, all of it.
Exactly. It's like putting together a giant jigsaw puzzle, with each fossil providing a crucial piece.
What about the other Devonian site, the one in Nova Scotia? Does it give us a different perspective?
It does. While the Fern Ledges show us those terrestrial ecosystems, the Nova Scotia site takes us into the Devonian seas.
Oh, back to the water.
Back to the Age of Fishes, exactly. The book describes the Arisay group, a series of rock formations with an amazing array of marine fossils.
Okay, I'm ready to dive in. What kind of creatures are we talking about here?
Oh, it's a fossil hunter's paradise.
Yeah.
Trilobites, brachiopods, corals, crinoids, and of course, fish fossils galore.
So we're seeing the Age of Fishes in all its glory. Are any of these fish related to the ones we see today?
Some are, but many represent lineages that have gone extinct. The Devonian was a time of experimentation in fish evolution.
Experimentation, like what? Different body shapes, different lifestyles?
Exactly. Some lineages led to the first amphibians, others went extinct. The Arisay group lets us trace the rise and fall of these different fish groups.
So we're not just looking at fossils, we're looking at the tree of life.
You got it. And Acadian geology helps us understand those connections, how the Devonian period laid the groundwork for the evolution of all vertebrates.
Wow, even ourselves.
Even ourselves, it's all connected.
This Devonian deep dive has been incredible. It's amazing how much information is packed into those rocks.
It is. And it's a reminder that the Earth is constantly changing, and the Maritimes hold this incredible record of those changes.
Okay, we've done the Carboniferous, the Devonian. That's a lot of geological time travel.
Now, we're not done yet. There's still more to uncover.
More. What other periods are we talking about?
Let's go back even further to the Silurian period, a time when the Maritimes were completely different than they are today.
Okay, the Silurian. What was this region like back then?
Imagine vast, shallow seas teeming with life. Volcanoes erupt on the horizon while continents collide, pushing up mountain ranges.
Wow, sounds dramatic.
It was, and Acadian geology gives us a glimpse into this turbulent period. The Silurian rocks are often heavily folded and faulted.
Folded and faulted, what does that mean?
It means they've been bent, twisted, broken by the forces of plate tectonics. Ancient continents crashing together, reshaping the landscape.
Wow, so those folded rocks are like scars from those ancient collisions.
Perfect analogy.
Mm-hmm.
And amidst those deformed rocks, we find fossils, revealing the creatures that lived in the Silurian seas.
More trilobites, I'm guessing?
Oh, definitely trilobites, but also brachiopods, corals, crinoids, and even some early fish.
Okay, so we're moving from the age of fishes to the age of trilobites.
You could say that. And the book highlights the diversity of those Silurian trilobites. Each species tells us something about the environment it lived in.
So, like, detectives were using those fossils to reconstruct the Silurian world.
Exactly. And that's what's so great about Acadian geology. It doesn't just present facts, it guides us through the evidence, helps us understand how geologists think.
It's like we're learning to be geologists ourselves.
That's the idea.
Yeah.
And we've only just begun to scratch the surface of the Silurian. There's still so much more to uncover.
Bring it on. I'm ready for more geological adventures.
Well, get ready, because we're going back even further in time in the next part of our deep dive.
Wow, that Silurian period was a wild ride. Volcanoes, colliding continents, ancient seas teeming with life. It's amazing how much geological drama was packed into that one period.
It's a reminder that the Earth is constantly changing, and the Maritimes have seen it all. But you know, Acadian geology doesn't just focus on those ancient environments. It also explores the practical side of geology, like the economic implications.
Oh, right. The book mentioned mining and how the Maritimes had these deposits of iron, gold, copper, all that stuff.
Exactly. The book really gets into the history of mining in the region, how those geological resources were formed, how they've been used over time.
I can just imagine those old gold rush towns, prospectors panning for gold in the rivers.
Well, the Maritimes didn't have a gold rush on the scale of California, but gold mining has been important here.
Makes sense with all those deposits associated with the Maguma terrain.
Right. The book talks about how those deposits have been mined for over a century.
It's amazing to think about how those ancient geological processes like mountain formation and mineral deposition still have an impact on us today.
It really highlights the connections between geology and human history, how the Earth's processes have shaped our lives and societies.
And speaking of shaping our lives, Acadian geology also talks about how understanding geology can help us with things like resource management, environmental protection, even dealing with natural hazards.
Absolutely. The book emphasizes the importance of things like geological mapping, analyzing the ground to understand where landslides might happen or earthquakes, things like that.
So we can use our knowledge of geology to predict and hopefully prevent some of these natural disasters.
Exactly. And it also talks about how understanding groundwater flow and different rock types can help us protect our water resources and prevent pollution.
So it's not just about understanding the past, it's about using that knowledge to make better decisions for the future.
Precisely. It's about applying geological knowledge to solve real-world problems.
Wow, Acadian geology has really opened my eyes to the importance of geology. It's not just about rocks and fossils, it's about understanding our planet and our place in it.
Couldn't have said it better myself.
Hmm.
It's about appreciating the interconnectedness of everything, how the past shapes the present, and how our actions today can impact the future.
Well, this has been an incredible journey. I'm already looking at the world around me differently, seeing the stories hidden in those hills and valleys and rocky coastlines.
That's the power of geology. It transforms the way we see the world.
And Acadian geology has been an amazing guide on this journey, leading us through the complexities of the Maritime's geological history and inspiring us to think like geologists.
It's been a pleasure sharing this journey with you.
Thank you for joining us on this deep dive into Acadian geology. We hope you've enjoyed exploring the fascinating world of geology with us. Until next time, keep those minds curious and those brains engaged because there's always more to learn, more to explore, and more to wonder about in the grand story of our planet.